All right, so today's lesson is almost exactly like yesterday's. The only difference is that we're using 3 variables instead of 2. So today's essential question is, how do I solve a 3-variable problem with matrices? So we're starting out with just naked math. We've got x plus 2y minus z equals 4, 2x plus y plus z equals -2, and x plus 2y plus z equals 2. So I have my 3 equations. They're set up with an x column, a y column, and a z column, exactly what we want. We have all of our variables on one side and all of our constants on the other. So all I need to do is pull out those coefficients. So the x here, there's no number there. We just write 1. We have a 2. And I'm running out of space here already. I'm really bad at that. So 1, 2, 1 for my first x column. Then I have 2, 1, 2 for my y column. And -1, 1, 1 for my z column. Then I'm going to have my variable matrix of x, y, and z. And then I'll have that equal to, because right now they're being multiplied, equal to my constant matrix of 4, -2, and 2. And so this is matrix A, this is matrix B, and I need to find A inverse of B. So this time when I type this in my calculator, I just need to change the dimensions of my matrix. So I'm going to hit second matrix, arrow over to edit. I now have my coefficient matrix is a 3 by 3 matrix. So I need to change the dimensions so that it's 3 by 3. The numbers are 1 going across 2, -1. Then I have 2, 1, 1. Then I have 1, 2, 1. And I'll exit out of there. And then I need to edit matrix B. And so matrix B is now a 3 by 1 matrix. So I have 4, -2, and 2. And I will exit out of there, and I still want second matrix A inverse second matrix B, now that I've edited these. And so you'll see that I get some decimals. So not pretty, but all I need to do is hit math fraction, hit enter. I get -5/3, 7/3, and -1. Okay, so our second example here, we're going to take, again, we see our x's, y's, and z's are all in columns, which is exactly what we want. So we'll write 7, 3, 5, 5, -5, 3, and 3, sorry, -3, 2, and -7 as our coefficient matrix. We have 3 equations with 3 variables. That's a 3 by 3. And then we have x, y, and z. Those need to go in the same order as the columns. So x is the first column, so x should be the first row in your variable matrix. Y is the second column, y is the second row in your variable matrix, and z is the third column from your equations, so z should be the third row in your variable matrix. And then we have our constant matrix of 16, -8, and 0. So now we're going to plug this in for A, plug this information for B, and solve for A inverse B. So when we go to type this in our calculator, we hit second matrix, we edit our 3 by 3 matrix, and we type in 7, 5, -3, 3, -5, 2, 5, 3, -7, and then we'll edit our matrix B, which is a 3 by 1 matrix of 16, -8, and 0. And so it should look like this. And now we'll second quit to get out of there. Second matrix A inverse
second matrix B. Ooh, I just hit inverse twice. Whoops. Second matrix A inverse, did it again. There we go. Second matrix B. And we get 1, 3, and 2. So x is equal to 1, y is equal to 3, and z is equal to 2.
All right, and so now we're going to talk about using these word problems for 3 variable systems. So I know that this is blurry, I know this is hard to read from the video, but you do have this in front of you at this point. So just follow along. We have this Arcadium in Lynchburg, Tennessee that uses 3 different colored tokens for their game machines. For $20, you can buy any of the following mixtures. So there's 3 different combinations, all for $20. We're going to write those into variables. So we're going to say the gold tokens will be G, the silver tokens will be S, and the bronze tokens will be B. So if I look at the first scenario, I have 14 gold, 20 silver, and 24 bronze that I can buy for $20. The second scenario is 20 gold, 15 silver, and 19 bronze for also $20. And the final one is I can buy 30 gold coins, tokens, 5 silver ones, and 13 bronze for, you guessed it, $20. So I have my gold, or my G column, my S column, and my B column. So when I go to write my coefficient matrix, I have 14, 20, 30, 20, 15, 5, 24, 19, and 13. Then I have my variable matrix of G, S, and B, and that's equal to my constant matrix, which is 20, 20, and 20. So now I'm going to use my graphing calculator to plug these in these matrices and figure out how much each coin is worth. So when I go to type these in, I am going to hit second matrix again. Hopefully you're getting really good at that. I'm going to edit, arrow over to edit, and edit this 3 by 3 matrix. So I have 14, 20, 24, 20, 15, 19, and 30, 5, and 13 for my first matrix. Second quit, second matrix. Arrow over to edit and go down to B. We're going to edit matrix B now. So my 3 by 1 is just going to have 20, 20, and 20. All of those are $20. So I will enter second matrix A, inverse second matrix B. And I get 50 cents for a gold coin, 35 cents for a silver coin, and 25 cents for a bronze coin. Please make sure that you're writing those out and not just listing your matrices, but in a word problem, you need to put it back in the context of the problem. So listing what each one represents is important. You flip your sheets over on the back, and you'll see that we are going to be dealing with some money for our next equation. So John inherited $25,000. I wish I inherited $25,000. And I'm actually going to set up each of my variables to start. So we have X, Y, and Z. You can use whatever you'd like. I'm going to use X, Y, and Z. For X is going to be the money market account. Money market. Y will be my bonds. And Z will be my mutual funds. Sorry, I got a little carried away. I called it mutually funds at some point in this word problem. So mutual funds. And I need to write 3 equations. Thankfully, there's 3 pieces of information that we're going to deal with. So if we know that there's $25,000 and you split that up amongst the 3 accounts, and you have x plus y plus z. So all that money is equal to $25,000. But we don't know how much John put in each account. So we have x plus y plus z. Then our second equation talks about the interest. So we're going to take a percentage of that amount of money that we put in initially to talk about our interest. So we have some percents here. We have the money market, which is 6%. This is a percentage. We want to use the decimal equivalent. So we're going to move the decimal over 2 places. So 0.06x. Then for the bonds, we have 7%, so plus 0.07y, because we've changed 7% to a decimal. And then our mutual funds, here's my, I told you I called it mutually. Our mutual funds paid 8%, so that'll be plus 0.08z. And then the money that we gained from the interest, so 6% on the money market, 7% on the bonds, and 8% on the mutual funds, that totaled $1,620. So we gained this much money from that $25,000 that we had. That's pretty cool. Really still wish I had that $25,000. And then the last equation, I will tell you that this is usually the most difficult for me to write, and it probably will be for you as well. And so I just like to break it down. There was $6,000 more in the bonds than the mutual funds. That statement sometimes is really difficult for me to write an equation from, the way that it's worded. I don't know why, it's just the way my brain works. But I usually like to take a step back for a second and ask myself, so which one is worth more? If there's $6,000 more in the bonds, then the bonds is going to be bigger. The bonds is going to be bigger. So my bonds was my y, and so that's equal to the mutual funds plus $6,000. So the mutual funds were z plus $6,000. So that's how I have to think of it. As I know that there's going to be more money in the bonds, so I take the smaller one and I add the $6,000 to it to show that that's more money. Now the problem here is that we have this equation that does not match our model, that we need to have all the variables on one side and all the constants on the other. And this one we have a z on the right side and not on the side of the other one. So we're going to move that z over, and I'm going to write this to have 0x, because I don't use x in this equation, but we'll still need a coefficient for it. So it's going to be 0x plus y minus z equals 6,000. And now I have all of my variables accounted for, 3 equations, 3 variables, and so I can write my coefficient matrix. So when I write my coefficient matrix, I'll end up with 1, 1, 1, 0.06, 0.07, and 0.08, and 0, 1, and negative 1. Then my variables were just x, y, and z. That's a terrible z. And then my constant matrix has the $25,000 that I wish I had, the interest of $1,620, and the $6,000 more that the mutual funds needed added to it, so 6,000 here. And so I'm going to type these in my calculator to determine how much money was in each account to start. Alrighty, so turn your calculator on, and we'll clear the last problem. So second matrix, I'm going to edit my 3x3 matrix so that I have ones across the top, 1, 1, 1. I have 0.06, remember that decimal, or that percentage needs to change to a decimal, 0.07, 0.08, then 0, 1, and negative 1. And then I'll exit out of that screen. Second matrix, edit matrix B. This time I should have a 3x1, 25,000 in the first spot. The second equation used 1,620, and the last one was 6,000. So when I finish there, I hit second matrix A, inverse second matrix B. And
So I ended up with, or at least this is what I started with, I guess, $15,000 in the money market account. There was $8,000 in the bonds and $2,000 in the mutual funds when John inherited that money. So please make sure that in your notes you're writing down what each of these represents and not just X, Y, and Z, but that $15,000 in the money market, $8,000 in the bonds, and $2,000 in the mutual funds to fully answer this question. Okay, so really hope that you're starting to get the hang of writing these equations. Once we have the equations, the matrices that make it pretty simple to solve. So our last one here, we have Billy's Restaurant that ordered 200 flowers for Mother's Day, and they ordered carnations, roses, and daisies. So I'm going to use, C for carnations, R for roses, and D for daisies. So C, carnations, R for roses, and D for daisies. And so there's 200 flowers, so we know that all of those combined, C plus R plus D, is 200 flowers. And we know the price, so we have $1.50 for carnations, $5.75 for roses, and $2.60 for daisies. So those become our coefficients when we're talking about money, and then the grand total for that was $589.50. So that's what that equation is equal to. The last equation talks about how many of the flowers they ordered. They ordered mostly carnations, which really isn't a specific number that we can use in our equation, so we're actually just going to care about the fact that there's 20 fewer roses than daisies. This is another one of those things where I look at it, I'm like, I'm not sure exactly what that means. So I always ask myself, which one has less? Is there less roses or is there less daisies? Well, this says 20 fewer roses than daisies, so there's going to be less roses. So if I take the roses and equal that to the daisies minus 20, that means that there's 20 less roses than daisies. Now I do need to change this equation because this is not in the form I want it to be. I want all of the variables on one side and I want all the numbers on the other. So I'm going to move the D over, and so now I have 0C, because we didn't even talk about the carnations in this equation. My R comes next, so plus R minus D equals negative 20. So now I have my C, R, and D kind of lined up in that column for me. And so now I can write my coefficient matrix. I have 1, 1, 1 across the top, 1.5, 5.75, and 2.6, and then 0, 1, and negative 1 for that bottom row. Then my variable matrix is going to be C, R, D. Make sure that those are in the order that you wrote them. And then finally my constant matrix, as these are being multiplied, my constant matrix here is 200, 589.5, and negative 20. And so we're going to type matrix A and matrix B in our calculator and solve for A inverse B. Okay, so second matrix, we're going to edit our 3 by 3 matrix. We have 1, 1, 1 across the top, 1.5, now I wrote 10.5, 1.5, 5.75, and 2.6. Then I have 0, 1, and negative 1. So I'll get out of that screen, and then I'll edit my 3 by 1 matrix. So my constant matrix has 200, wow, not 200. I want to make that a 3 by 1 matrix. 3 by 1, got a little crazy. Okay, so here we go. First element, 200, 589.5, and negative 20. So second matrix A inverse second matrix B will give me that there were 80 carnations, 50 roses, and 70 daisies. Now, that tells us that we did have mostly carnations. There was 80 carnations. That answers that portion. There's 20 fewer roses than daisies. There was 50 roses and 70 daisies. So 70 minus 20 gives us 50. And if we add all three of those numbers together, we get 200 flowers. So be sure to write your answer clarifying what each of those numbers represents. But now you guys are going to be working through some problems with 3 variable systems and using matrices to solve them.